I know we oftentimes are very focused on new construction, but how we repurpose existing structures is also very critical to the industry. So Brianna, why don't you go ahead and take it away?
What we were talking about is obviously as-built and existing conditions where you aren't working with this perfect situation. So we were doing a use case based on an owner, Nathan, who has a historic building that does not have the ideal conditions with perfect flat floors and walls. So what the owner did was he defined the tool, activity, and output so that we could figure out what type of reality capture and technology we wanted to use to meet his project deliverable. So most important thing is, how is this information going to be used down the road? Can we trust it? How do we verify it? And then where are we going to run into issues with the data when trying to create like a model from it? And then we need a way to be able to continuously update the source of truth. So we ended up circling back on like 5 of the other reality capture roundtables that we've had before about you have to be able to trust things. You have to be able to have an owner or a contractor that is going to keep the source of truth, and that you have to understand that there's not always going to be perfect conditions, and you have to understand how to work with the data and what other types of data you need. So recommend listening if you ever have a project where you're doing any kind of existing conditions or remodels. Lots of great perspectives from people who have been through lots of these problems before. It off with participant introductions.
Hey everyone, I'm Ben Stocker. I'm with Skender, general contractor based in Chicago. I'm our construction technologist here. And need any other details?
What is the relation to historical preservation to you?
What is the relation to me, or like how is it important, or like what?
How is it important to you? Yeah.
I mean, it's key for just keeping historical data of all the projects that we work on so that we can go back to them, whether it's for service work or if we start another phase later, or just to cover our asses if something comes up in the future. Yeah, it's important for all those reasons.
Awesome. Okay, we're going to move on to the next one here. We're going to have Blaine give a quick intro of himself.
Yeah, Blaine Grantham, principal and one of the owners of Titan AEC. Basically, we've been laser scanning since 2010 as a means of just getting correct information. Historical preservation, we've done a lot of that for USC, and we're about to kind of tackle a project in the Bay Area too. So one of the key things about that is making sure that whatever gets constructed on site matches the decor of that building when it was built back in the 20s, the 1910s, 1880s. So it's really important. I think we've gotten a long way with on the reality capture side, both with photogrammetry and laser scanning, to make sure that happens.
So just a little bit of overlap and relevance for you in this topic.
Wait, Brie, can you just pin Blaine and me together? Can we just have like a beard war real quick?
Yeah.
You look good,
I think
man.
you got
Give me 1 second. Let me put you up there. Who else on the call has got a, okay, we got Josh has got a beard too.
Yeah.
Yeah, who's got the best COVID beard?
I need to unpin myself from this, or like get a fake beard. I don't belong here.
We'll figure it out.
Okay.
Sorry, I digress. Thank you for recording.
Awesome. Next up, Patrick Ramirez.
So my name is Patrick Ramirez, Arizona Local 469, plumbers and pipe fitters. I am the virtual design construction coordinator, plumber by trade, tech by noose. I got roped into it a long time ago, and apparently they thought I did a good job conveying the information to the apprentices and journeymen. So then the UA put another rope and lasso on me and pulled me to the national level. And so I teach laser scanning there. Historical preservation, probably the fundamental pin in that is to convey to the students and to our membership the responsibility of recording what we're doing as the progress goes through the project, but more importantly is outreach programs for the local community and being able to capture that data for them, show them the importance of being able to get good, valid, accurate information. So we've done a few older style Mexican churches, things like that, the Spanish facade on the exterior of some of the buildings. So we've captured some of that stuff. We did the California Zephyr 1952 train. Before my wife sold her 1952 Power Wagon, we historically scanned and documented that. So that was fun. And we use that in the different training methods and talk about how you capture different information and what it can be used for.
Awesome. Thanks, Pat. And I see Lisa's here.
Hey guys, it's Lisa Duncan. I'm one of the co-founders of, hey Patrick, of Innovative Construction Technology, so or ICT Tracker for short, and glad to be here today. Glad to see everybody's friendly faces.
And if you could give us one sentence as to why reality capture for historic preservation is important to you, that'd be great context.
Oh gosh, what a loaded question. Well, obviously, you know, all of us have been in the industry and seen the use or the need for historic as-builts to for retrofits and renovations and so on. But ideally, it would be useful for continued facility maintenance and just overall management. So I would, you know, like to have it there for an ideal use. I know it's not always the case, but very, very important to first of all have an as-built and that, you know, historical as-built. So if we can get there, then we can use it for operation and maintenance and so on. So that would be my thing.
And I see Peter's joined us. I'm going to quickly pin you, add one more person to the intro here.
My name is Peter Lasensky, and I founded NoteVault, which was acquired by Bentley recently, or this last year. And so I now work for Bentley in product strategy. And my interest in reality capture is really as it relates to, documenting progress of construction. That's the area that I think, I think there's a lot of great areas for it, but that's, near and dear to my heart. So.
And it's really hard to document progress if you don't have a baseline or something like an as-built to create the foundation for it.
Yeah, that's right. So, I mean, there's always questions. You don't know what the questions will be, and you can make notes and you can take photos, but if you can do scans routinely, that's pretty much going to answer the questions.
Yeah, absolutely. Okay, cool. Well, now we're going to actually move on from introductions and we're going to give a quick overview of what we're talking about. So what we're talking about is how might we decrease the cost to restore existing conditions on historic renovations. And the example that we're talking about today is actually in Nathan's home. He has an older historic home and he is looking to do some work and does not have any sort of as-builts. So we're really talking about, he's, kind of the customer in this situation. He's the person who's trying to create something. So what we're looking at is how can we use the latest reality capture technologies to address previous scan-to-BIM constraints so that the reutilization of existing is both economically and environmentally sustainable. So with that being said, we've got a couple of use case perspectives that we're going to be going through. We've got Dustin, who did our laser scanning for us. We've got James Norris from ClearEdge. Dustin Williams from FlywheelAEC. Then we have James Norris from ClearEdge, who's going to be talking about what was done with some of the scans. And then Jackson, who's coming from the field perspective, where he's going to be thinking about how he can use this information for installation. So with that being said, I'm going to now switch over to the Miro board here, where we have kind of another version of the how might we statement. So we're using reality capture hardware and software to produce reliable as-built conditions. So as-built is where it all started, which is what each of the people who gave intros of themselves said is, you know, we need to have some kind of as-built if we want to do something new with the space, if you're the owner and you want to change something. But what we're trying to do is we're trying to enable design for manufacturing, or DFMA, of this historic renovation. And that's what Jackson's going to be highlighting. And the goal is that, you know, phase 3, the build schedule, has minimal impact on the occupying client. So how can we create as-built conditions designed for all this prefabrication to happen, not on site, not impacting the tenant or the client, and then get all those materials so that when they come to the site, that they fit in true form to what the conditions are. Now I'm going to jump over to the picture here, and this is where I'm going to pass the baton to Dustin, where he's going to talk about the first step in this, which is, you know, starting to scan the space. So Dustin, go ahead and take it away.
Sure, thanks. So obviously as-built thing is super important. I think everyone here is intimately aware with why it is. So on this particular project, we actually even do have as-built, and I think that what's worse than having not good as-built, these as-built coming from the city are signed off by the structural engineering department are absolutely incorrect. And so if they were to be taken at face value, you may have, I mean, like the average homeowner could have easily taken these over to their architect of choice and started that whole design process with some fundamentally wrong information, which would obviously completely have to go back and change the design to meet the real existing conditions. So our friends at Faro were nice enough to loan us. This is the Faro S350, and this being, you know, this is a smaller scale than like a commercial building. We did about 22 scans, I think, throughout the house. There's a basement, the first level, and an attic. And then the idea is to capture data good enough to enable us to do some offsite manufacturing of trusses and things like that, and really try to prove out some of these things that we're doing on a larger scale for more like commercial development currently. And the nice thing with this, obviously, this is a more accurate as-built than just taking a tape measure to things. Obviously, these walls are not plumb, and there's a lot of interesting structural work that's happened over the years, and obviously with the millimeter accuracy of the laser scanning, we're going to be able to document that and hand it over to the architect. So this is the first level of his house, and I think what we should do is just kind of walk through. Nathan put this together. It's kind of an overview of some of the things that we've done to date, and then some of the things we're looking to do, and how they're interconnected. So you can see on the left-hand side, identifying from the bottom, just identifying like the hardware that we use to capture it, some of the software we use to then register things together, some of the outputs, and I can walk through this in more depth, and then James can obviously even go even deeper into some of the things like edgewise. So let's just do that. So the plan is, well, we have already done the laser scanning and registered it together. What we're gonna do another like short update. The plan is to also do photogrammetry using a Phantom 4 RTK, and then tying all of those things together with the city benchmarking system and localized control points. So that's the baseline and the hardware end of things. The city of Denver, as most places, a lot of municipalities at this point are transparently providing current benchmarking system that is being kept up to date. So we're going to tie into that as opposed to doing some sort of assumed local coordinate system. And part of the reason we wanted to do that is Nathan would like to do a sun path analysis. So just tying it to a known coordinate system will make that really a lot easier, right? So, so we're starting with the laser scanning data. It is getting registered together, all those scans, brought into one unified point cloud, and then we're extracting out what we need. In this case, we're going to use Edgewise to extract out that information and to create a BIM so it can be used in Revit down the line. Like, sort of in that same vein, once we do the photogrammetry flight, we'll process all that together in a separate software, probably Pix4D. That's what we typically use at Flywheel. And we'll export those files to something that's really good interoperability wise. We like to use E57 and LAS files from drone flights. And then typically we'll create a recap file just because the Autodesk engine prefers that, and it works really fast in the Autodesk products that we'll be using downstream from this. Edgewise will accept both of those, actually, both the recap and the E57, but we've started to bring that in and started extracting out the basement walls, and we're going to move up the levels as we move forward here. I'll let James go into deeper dive on that in a few minutes. What's up of the BIM and reality capture coordination? I think that's just identifying that, like, a federated, if you will, recap model, which will include both the photogrammetry derived point cloud and the laser scanning point cloud. And then Nathan's got himself at the top, I guess, for owner input and really at the very beginning identifying what he was hoping to do, which was this kind of like great as-built so they can do some smart decision making and hopefully some off-site construction. He lives in a city like a lot of other people, and I think that being able to bring some of that stuff in pre-assembled and then just craning it into place is going to be hopefully a time and money savings for him, just like it is on a lot of other types of projects. Once you move past that green line to the right, which is boundary of alignment, we're obviously going to have the fully scan-to-BIM like Revit model, and that'll get handed over to Josh, our architect. And then that'll enable us to do different things. We'll bring all of the things we mentioned really into something like Revista to do collaboration and letting all the stakeholders really look at all the data all put together and make comments. And I guess in anticipation of some of those blue items there, which are creating the permit drawings, getting the bids sent out. So I think the plan is it can be done. I think he's going to share this with his people bidding on the project. So that might be new to them, but maybe not too. We're in Denver, so there's a lot of forward-thinking people here. And then design for manufacturing and shop drawings, right? So that was the pre-construction kind of stuff, or off-site construction, I should say.
So Dustin,
I kind of burned through that. I think we should revisit. I don't know if anybody, I guess we should just start at the bottom, I guess, to see if anybody had any questions or even like suggestions on additional information that you think might be needed, or any of the kind of parameters we use to create the data.
I mean, just one thing, it looks pretty complicated just looking at this. And it looks like a lot of work and manual setup. Is that really the case, or is it just?
Well, I think this is like a group of construction technology kind of geeks trying. So this same process is what we would typically see being used even for commercial, just this is a smaller scale. It looks complicated, but because it is a smaller scale, the time to perform all these things is really not that complicated. with it being planned out like this. So like shooting in the coordinate benchmarks, you would do that on any project, but in this case, we only have 2 points to shoot in because it's, you know, they're right adjacent to the property. And the laser scans, we only have 20. We're not, you know, it's just not hundreds of thousands of square feet. It's just, you know, 1,500.
Yeah, and I think another thing, what's different, right, is kind of if you compare to kind of traditionally how as-building was done with a measuring tape, or even if you maybe you started off with the scanner, the goal is to remove as many human touch points as possible to kind of avoid the kind of natural human error that happens throughout a process. So while this seems like there's a lot of plugs, the amount of human touch points that would be involved in a more traditional process would be way more. So you end up with a lot of kind of a human error that's no fault of anyone's, just it happens. And to kind of bring as much automation as you can as well, right? So while it is scanning, you know, we don't have to, the registration process takes, you know, an hour after you've scanned, and 20 scans you can do in easily in a morning, maybe a full day depending on the scanner. So, and I just, you know, I think of that in terms of what that would take, you know, for a lot, especially residential, right? You know, you'll have an architect go out there and measure with like a line laser maybe. So you just end up with all this risk. So yeah,
I think there's some efficiency too, and like,
sure,
maybe it seems like overkill, but just like we were talking about before, where we're extracting out the walls and creating a BIM, and then we're using just that area of the point cloud as context. So you know where the light switches are and things like that you can avoid. You have a lot of really, really good context that you wouldn't have to make any assumptions or maybe go dig back through like the site photo you took when you're out using your tape measure. So some efficiency there.
And if we're playing through like the tool activity output, the tool we have here is the laser scan. The activity that we're doing is we're scanning to get as-built to create design documents. So we really need to use scanners to get design document accuracy, especially with the historic building where we know the floors aren't level, we know the walls aren't level. So our options are, you know, do we pick a tool that doesn't give us the right output? And in this situation, we said maybe a little bit more complicated of a workflow, but it's going to give us the output that we want, which is extremely accurate model for DFMA. So if we know that the output is for DFMA, it has to be that level of accuracy. So that's, you know, circling back to the how might we statement, that's the reason we picked this seemingly more complicated workflow, but the output is requiring the more complicated of the outputs.
The other thing to consider is, as complicated as this drawing is, the visual of it clarifies any of the questions that might be asked in the linear form that you would typically get on a project execution plan. Who's doing it? How are they delivering it? Where's it going? Who's the responsible party for managing that data? All of that, if you have it on a document, yeah, it looks a lot cleaner.
And what are the different use cases that are being done with this data? I think that was, you know, in past roundtables we've talked about, you know, people don't want to share reality capture data because it could be used in the wrong place. But if we put this document together and we say this data can feed all these locations, we've set that precedent at the beginning, just like you said, Pat, then it gives people the comfort to be able to know what it's going to be used for.
So if I can,
separate use cases
jump in
within
here.
a common objective.
Yeah. Go ahead, Blaine.
So, you know, when it comes down to like reality capture, and especially dealing with any type of building where you have an existing structure, you have to kind of pull that information in. We always have to look at it based off of what's our ultimate end goal. You know, what are we trying to get out of it? And we found this true at LAX with the work that we're doing there. So you're looking at a notoriously large airport, you know, lots of square footage to cover. But what's our ultimate output? What's the owner ultimately want out of this, and what we're going to use it for? In this case, with what we have in this document, it basically expresses that in a way that makes sense. So you're looking at the end output, like, hey, we need to basically submit this for permit, specifically on a historical building, and we have no idea what's really there. You may have drawings, but like we said before, and Dustin, you're absolutely right. These drawings most likely are not accurate because it wasn't built that way. Because especially with these older homes, historical buildings, you'll have a set of drawings from a master builder like an architect, but then you'll have a contractor out there that has to change things in the field. So a wall may not be, you may end up putting a pop out into a residential home that wasn't even on the plans, or that may be something that's got added 10 years down the road by the next owner. So the output that you're going for absolutely forces you to utilize all these tools. Now, granted, this is a bunch of geeks doing all this work, so this is fantastic. We guys are going to geek out.
Since we are geeks, I think it's worth bringing up, James. I don't know how well you remember it. Our discussion on like the different ways that a wall that isn't straight can be represented from the point cloud, right? Do you remember that part? Because that was like
what wall is straight?
Yeah.
Yeah.
And I think that's another thing.
Is it the outside face? Is it the average? Does it need to be plumb? Like you got to pick one.
You do.
Based on how you're going to use it, right?
Yeah. And I think that's in Nathan, that's a great discussion. Like, do you really want to make the wall not plumb inside your design drawings too? Or do you just want to notate that and make sure they understand that? I think we've always had to debate internally, like, do we really want to make this wall not plumb? Because it's going to look like garbage inside the design software. If you're using Revit doesn't like non-plumb things at all, period. It hates them unless you let's use 2021 now, where you can actually provide a cant to the wall that wasn't there before, but it just doesn't look good. So do you need it that way? Do you need to have that non-plumb? Some of these walls are twisted. Now I'm going to put this up for debate here. I think some of the builders that built these original homes back in the 20s and early on, they knew how to build plumb walls. I think guys nowadays don't. From what I've seen.
You eye it up. Sometimes you have to put it out of plumb to make it look good.
But yeah, if you're, I think that comes back to,
especially on an old house.
Right. I think when it comes, we were talking earlier, right, about what the end in mind is. So if you're doing prefabrication of an existing system, you want to know exactly where that wall is. If you are working with nominal dimensions because you're adding on to, I don't know, an addition, it may be fine to go nominal. And then, you ask that question, are we going to snap the walls to the face so that the geometry is automated in a way that you would normally naturally model in Revit? But these questions are important. And definitely a topic that came up when we were at that point in time.
Yeah, this is actually something Josh, the architect of the project, brought up is, he's doing everything in parallel to this. So he's creating as-built the traditional way, where you just go out, you measure some things, and you do it without all the scan data. And then we're also doing the path of scan edgewise or scan photogrammetry edgewise, then get the model. So we're doing it in tandem to be able to see, kind of the pros and cons and benefits of some of the different workflows that you could do.
Yeah, Josh is here. Let's hear from him real quick, because you made a good point of like, why would you want to trace something? Kind of like just like the old estimator says, like, I don't know the project until I've kind of traced it with my quantity takeoff, whatever. But you want to talk about a little bit of that discussion?
Yeah, and some of what you and I had talked about too, it's how do you create your program early on before you're having to put together your scans, right? So you need to understand the space as an owner or as a client in order to communicate your idea. Yeah, granted you got your scan, but is that wall a double wide brick wall? Is it got studs in it? Like, is it just a concrete wall with block? Nobody knows, right? The scanner is not going to tell you that. So there's some level of investigation that has to happen, but much to Blaine's point, the walls are straight up and down, or they're not straight up and down, but in my Revit file, they're going to be straight up and down because it has to represent that in a 2D environment clearly, right? Like, because when you start cutting things, I've run into that on another project where the walls were tapered, but the architect took all of his dimensions from 4 foot above finished floor. Well, what does the GC do? He takes those dimensions and he goes out there and he starts marking those off on the plan, but
it's the wall in the wrong spot.
Exactly.
Rework.
So we've had to take walls down because of that. So
George.
Yeah, I think the cool thing, you know, is it's kind of like you do the method where you know, you draw from the scan, you draw from measurements, and then if you have this kind of automation going on in parallel, you can compare the two and see where there may be some massive red flags. So in some form, it can actually act as a really good QA/QC tool, right? Because you know you have your end deliverable and something you need to print out for documentation. And I think that's you know, very important, especially when you're doing historical type projects. I mean, I've been on tons of airport projects. So, and you know, they are never, you know, there's always constant change happening without the documentation occurring. So, I mean,
Yeah.
I don't know.
I have a question for you guys. I don't know if this makes sense or not, but is there anything available that would be like a sonar that would identify, you know, studs and plumbing inside walls and that kind of thing that you could layer onto this to get some kind, even if it wasn't clear, but just to get some indication of what's in that wall?
There is.
Yeah, really.
You'll find it that they use a lot out in construction sites, especially with the existing construction. We're going to have that in Pomona Valley, where we have to go through a concrete encased beam, and the architect wants to penetrate the concrete to run a plumbing line up. I know everyone's thinking in their head like that's the dumbest idea ever. It is. It's a dumb idea, but we have to go out there and we have to take basically a scanner, which is
That's X-ray, right?
Yeah, it's not X-ray. It's not X-ray. It's more of it's electromagnetic. So you put the scanner up, it tells you where the rebar is. It gives you an idea of how deep it is.
That's a Hilti product or something, or
there's a few different ones out there.
Yeah,
and typically I stay away from it, but I let the experts work on that one. But at least it gives you an idea of where that rebar is encased in concrete. Works great for underground work. I mean, it's one of those things where if you got to do it, you got to do it specifically in any type of core through slab or wall. They use it consistently. But the problem is you're looking for ferrous materials. You're looking for things that are metal with this. So if you're talking about brick and stud, it's not going to exactly tell you where it's at unless it's doing it based off density. So, and even then that's something that someone else has to look at and basically interpret. And there are a bunch of different software out there that can interpret that. But then we have a problem of overlaying that. How do we incorporate that with our scan data? How do we incorporate that with the design data? So there's a little bit of extra work that goes into it. But in the case of a project like airport, you're gonna have to spend the money on that. And I think that's where we always run into everything. How much money do you want to spend in investigation and scanning prior to really getting into design? And so I'm going to kind of put this back, you know, in Joshua's hands, and of course James is, you know, we're trying to do things in parallel. One, to preserve costs on the tail end. We know that we're going to be up front. Sorry, Nathan, you're going to spend a lot of money in your house, but at some point, at least we'll have a better product on the end, and hopefully we don't run into those change orders, RFIs, situations in the field where you're going to spend a ton of money at. So like Josh, what you said is spot on.
Yeah, and bringing it back to, you know, our how might we, you know, pick a tool in order to get the scanned to as built so that we can design for manufacturing. So James, I'm going to let you talk a little bit about, you know, Dustin did the scans. What was the transition period? What were some of the pains that we experienced and some of the learnings that we felt along the way? And feel free to, you know, ask the audience or the rest of the group here if there's things that you want perspective.
Oh yeah, of course. So yeah, thank you, Brianna. So we basically went from capturing scan data with the Faro scanner, exporting that out as I believe they were E57 files. It may have been RCP. I think it was RCP. And then that was consumed by Edgewise building. And so, which at that point it says, hey, do you want to just automate geometry? And the answer is yes. Now, I think the lessons after that, right, was some walls were modeled. And it's like, why are walls not getting modeled? And it comes down to, there's a few things that happen because, you know, the algorithms are, it's somewhat, you can consider it like, it's human guided for some things. So if you've got, if you have a level and there's, and like the floor is really unlevel, So our algorithms are like they don't need to be super flat, but they need to kind of recognize that. And the more out of level something gets, it's hard for the algorithm to understand where the floor is, because it automates where floors are. It automatically creates levels, and then the walls snap to those levels. But that's why I think for us, never having utilized edgewise building for historic renovation was really interesting. And for us, it's like helping us kind of tune for like very, truly historic conditions. Because we ended up kind of going through identify the floor or the level, and then choose your walls, and then we'll automatically still model the walls, right? But I think, there was a lot there that, I think for us, for aiming towards residential was really cool. I think the benefit though that we got was it is still good practice to model on your own, I would say. So if you can, unless your fee doesn't make it, it totally makes sense to automate, right? Because you're trying to capture your modeling fee, and that's normally where a lot of risk is. Scanning makes money, modeling is scary. At least when I was doing consulting. And so I think that the nice thing though is what we did though is export the walls and all the scan data that was used to create those walls, the machine thought, actually gets imported and isolated. So you don't end up with like a very dirty point cloud. You end up with a very clean data that's like effectively a layer over the walls themselves, which is nice because then it's accurate. You know that switch is there, that those certain things are there, and you can use that as a reference point or model on top of that. But it was cool.
So just asking the group here, how many people on this call, or unmute yourself and add in if you've ever been a part of a project where the floors weren't level and in the existing conditions. Oh, I see Ben, he just unmuted himself.
Rhythm.
Yeah, this has happened a lot actually. This is also an answer to Brianna, but then also a question for James. Like when that comes up in Edgewise, are you able to say, I want to pick the highest point of the floor, pick an average, lowest point, something like that, and then create that flat plane there?
Yeah, so you can actually, prior to importing, you can say, hey, like with this project, I want the tolerance to be a certain thing. So it'll actually have a wider noise variance of like where the floor can be. A strong suggestion though is, once you've imported the scan data, you can just say, this is my level. You can choose scan data, you're like, oh, that's that level. And then you have your levels, and then you just automate the wall geometry.
Okay.
And then that just drops into Revit. And you can just use that as your basic source file for starting to model. You can blow away the walls if you want, but at least you know where they're at.
But there may be situations in DFMA where you're not going to want to pick the highest point on the floor or the lowest.
Right.
You may need to understand exactly what it is at any point on the floor as well.
It depends on what you're going to be doing with it afterwards.
Yeah.
Like for example, like in all the historical jobs where we'll go in, scan it and model it, and then are going to be using like just for BIM coordination and clash detection, we'll typically take the highest point on the floor and the lowest point on the ceiling, so that
your constraints.
Worst case scenario, you go out into the field and you had more room than you thought you did.
Mm-hmm.
That's better than not having not enough room. So yeah, we'll typically take that highest point on the floor, lowest point on the ceiling in that particular case. But yeah, there are other times, like you said, where you want to know exactly, you want to see that out of plumb wall, you want to see that not in level floor.
Which I think brings us back to why we put this document together. What are we using this for DFMA? Because if we're just using it for clash and coordination, we would want to set those constraints like you just said, Ben. So that's where like, how did we scan? How was it created in Edgewise is so important, because if we don't establish those at the beginning, we may have these, constraints set for the floor and the ceiling, but when it comes to Jackson doing the fabrication, that isn't going to be what works when we get the materials to the field.
Yeah, and what industry standard assumptions do we make based on exactly the reason you brought up, but in a completely different application, you throw that out the window. And that's what makes it so complicated, right?
As part of your, go ahead.
Oh, you got it.
I was just going to say the one instance in this actual scan that this is really relevant is there's a camber on one of the footing walls, and the intention is to dig out a little bit of additional basement area, and knowing that structural like zone of influence and what that camber actually is going to be really important for that little piece of this project for sure.
We're gonna structural engineer the shit out of this thing.
One thing that keeps popping in my head as we're talking about progressing through the workflow from scanning to get ready for production, one thing that we see that bites customers, especially in the residential sector, is they don't have drawings prepared for historic preservation reviews soon enough in the process. And so if you can create a photogrammatic model, and then instead of giving them a drawing, you could say your house has 15 original windows and 10 replacements, you can go, so these are the 15 we're going to replicate. These are the 10 that we're going to take out and put in new replications. And then you don't have to have individual shop drawings or individual, shop drawings submitted by the builder. You can do that from day one before it even goes to an architect, if you could do this yourself in a photogrammatic model. Because that's something that we see and we get a lot of money to do, is help people towards the end of the process create an exact shop drawing, and it's already going through 4 design iterations, when if you could scan it and just take a snap of the photogrammatic model and send it to them, say, this is what we're going to replicate. And then I have a DFMA file that is ready for production. I don't have to double up on work from the builder standpoint.
Yeah, I think I might kind of jump in here and piggyback on you, Jackson, a little bit. So on some of the projects that we've been working on, laser scanning is great, but sometimes laser scanning itself doesn't pick up the small details. So if we're talking about moldings, we're talking about trim, those small things we can get a pretty good understanding from the point cloud. It depends on how dense it is and how we utilize the scanner, what kind of resolution it's set up to be, and that could take up more time. So we started utilizing a dual process, and I'm not talking about utilizing my iPad or an iPhone to kind of get those details, because I'm still not sold on how accurate they are. But we've been utilizing a secondary product from Faro called the Freestyle. So we've been utilizing the Freestyle to really pick up those small details and incorporate that into our laser scan. So we do have some accurate understanding of kind of this handcrafted materials. And I can say, for one, doors and windows, they weren't manufactured, past the 40s necessarily. Most of this is constructed on site, glazed, and done all that work there. So having a really good understanding of what those consist of, how big they are, because not all those windows are the same size. They may be close, but they're not all the same size, depending on which carpenter actually worked on that specific door or window. So, if you want to cut glass or pre-cut glass and make sure those fit based off of what those designs are. And a lot of times when you're removing those windows on the historical side, there's some nuances to them. Your lights don't exactly line up. All those mullions aren't quite aligned perfectly like what we would have on a newer home. So capture it, understand it, and then at that point you can go manufacture it and then bring it to the site. Because having a glazer on site doing all that work while other construction is happening, a lot of things can happen that could basically break that glass. Or the glazing material doesn't set up properly. So you want to try to do as much as you can before you get to that point. So that's what we've been trying to do for some of these other projects that we're working on.
Were any of you guys involved in the Apple Cupertino headquarters and those giant windows and the concrete that didn't line up?
I was working at Clark Pacific that did all the structure and the precast, and it's talk about a crazy.
I've heard horror stories about them.
What was the plus or minus on the concrete on that one?
Don't do it. Don't answer.
No answering that. Come on.
One thing we worked on when I was back at Beck, we modeled the Smithsonian Castle because there were no documents, right? And same with, we were doing, I think, we were doing Tampa Airport at the same time, and we actually did use StructionSite. So we use StructionSite adjacent with the scan data, because when you're looking and zooming into profiles, right, because you can walk and like hit those right on those floor plans. It actually helped a ton because a lot of times from a user interface standpoint, it's very easy to navigate, which is very critical because like as you're designing, you're like not wanting, you're just trying to respect the bandwidth. So I think having something like, if you have a second monitor, you can have both the scan data that, you know, what's pulled up from StructionSite and, you know, and your modeling. It's very helpful, at least for our design teams.
That's bringing up, you know, multiple types of reality capture that paint the entire picture. And sometimes it may not even be a picture, a scan. It may be that you need ground penetrating radar, or you need x-rays, or you need some kind of, like Blaine was bringing up, magnetic, where you can see what's behind the walls. You may need multiple types of reality capture data to be able to set Jackson up for success when he's trying to not go to the field, tear everything apart, and then hand build it all and take, you know, 6 months. He wants to get all that information so that when he gets back to the factory, that he can build things and ship them to be installed.
Planning preservation for production. That's what we're after.
Ooh, that was a catchy slogan.
Well, I wanted to tap into what Blaine was saying, because that was really cool. Because we're thinking, what if with Freestyle or another scan model, if we can create a digital twin of those ornate profiles and then give y'all the model to design with. So you're designing your original model with parts that we know we can produce. We can let you take a mutton profile from 1775 that we've worked on before. We scan it, give you the cross sections. You can design with it in your model. You don't even need to at that point really scan the on-site data. You can just design with stuff that we've already scanned, and then you know this is the price for double hung to replicate a window from 1776. Could be a window from the White House. And so that's what we're after, trying to create a digital twin library of all the different profiles that we work on and see, because we see buildings as early as 1712 to 1940s. We have access to all these different ornate profiles. If we can scan them and then form a twin model, and that's where I'm not as clear on how to do that. But if we can do that and tie it to a CNC machine, or even just build custom knives for our routers, or for other machine shops to use knives that can provide those profiles, we can help shops all over the country to make sure that they're not getting close enough, they're getting exact. And that's what we're after.
And when you think about like the cost to build on site and the manpower, what is the cost difference of that compared to, just customizing your tooling so that you can do it in the factory? I mean, that cost comparison is, customize the tools so you can do it over and over again versus on-site build.
We're about $135 a person per day to travel out of town overnight, and then our labor rates are almost $15 more an hour to go into the field. And not to mention, brought up glazing. You want to glaze in a controlled environment so you can make sure it's cured properly, then it's sealed properly, so the longevity is going to be, those windows have already lasted 100 years. You want to make sure that it's in a controlled environment. But people get so behind on projects that you got to go to the site, produce, and then you spend more money and get way less value to the end user. And so it's just improper planning for preservation production.
Yeah. So Ben, I know you've got lots of field experience here. Any of this resonating? Any thoughts on like how you could think about scanning and reality capture for some of your, existing conditions or build outs?
I mean, yeah, we've used it a lot. I mean, existing conditions is the majority of the projects that we work on. We do a handful of new construction jobs, but most of it is existing conditions, especially in Chicago too. Like there's so many just old buildings we work in. I mean, just this kind of goes back to something we were talking about before too, but like we've had good examples where you're talking about wall plumbness, where we had to put, it's actually an ongoing project right now where we have a new 15-story building going in a it's around 6,000 square foot parking lot that is surrounded on 3 of the sides by existing buildings. And of course the designs just showed those three sides as just being straight up walls. And so we wanted to figure out like, all right, is this actually going to fit in here? Like, this goes back to the cover your ass comment. So like we were able to go in there and scan and essentially like figure out, where those existing walls around the perimeter of our new site, how are they pitching in? Are they pitching out? Luckily, they're all pitching out in this case, but I was able to tell the team, how much then, and like that's huge for them to be able to know that instead of just assuming when they go out to build, oh, we're going to be, flush right up against it.
Yeah. So you guys scanned and then pushed the scan information to the architect, or what was your flow of information?
I scanned it and then brought it into Build It to analyze it. Build It being the software. And then I was basically just made like a grid along each of the three walls showing, at this point, it's, 1 3/4 inches back away from that plumb line, basically just showing distances from the plumb line. And then I gave that to the project team and the architect so that they could help design around that. And this was like, we did that almost a year before construction even started. So that was very early into the pre-con process. So it was really good to get that information that early.
So one step that we haven't talked about with what we're doing with Nathan's house. I'm working kind of in tandem with what's going on with the laser scan. But we did have a conversation about similar to what you're saying, bringing that into Verity to kind of do that heat map comparison to say, okay, well, we drew it like this, but in reality, we're off by a little bit. So we can use Verity to create that heat map to say on that west wall of the house, it's going to be off by a 1/2 inch, right?
Yeah, you can do that. Or you can also, if you need, it'll automatically move the model geometry to where it really is in the world. So you can model nominally and then move it to where you want it to be and then coordinate from that. That's also really good if you're kind of, as you're building and doing, especially for the new buildings, you can track the structure and then, yes, do those heat maps. And that's what it's primarily used for.
Right.
So.
And we've utilized that tool as well to just kind of do floor flatness on our concrete.
Yeah, it's gonna be cool, man. I'm really stoked about this. With this, especially the fab portion. I really want to see Jackson's beautiful windows.
My challenge to Nathan is to make sure that we get a contractor that is on board with all this too, right? Because we are living in this virtual world, if you will, right? There is a reality to what we have to produce at the end of the day. So having all these scans is awesome, but if the guy at the end of the day is not going to use it.
Well, if you don't have anybody,
I know a good contractor.
Hey, well, we can help. Well, me and Ben will.
Careful, Ben. This is recorded. Nathan's going to watch it and he's going to call you.
That's right.
But I mean, in all seriousness, though, I mean, even for you, Jackson, we go through and on any project, you talk about fabricating, and even in this DFMA stuff, like you talk about where does prefabrication or fabrication fail, and that's at the unit of 1, right? Because now you've got three windows on this entire project, and you've gone and scanned and spent all this time, but in reality, your time was probably better spent just getting on a flight and going to his house and getting some as-built measurements yourself, right? Yeah. So, I mean, there is a scalability to what we're doing, which I think it's what gets me excited, right? Like we're taking it from this little tiny tool, but because we are starting so small, the most complicated things happen in smaller packages, right? So
it's way easier to handle. It's more agile to figure out the workflow so that you can scale it and make sure that you got everything covered.
Yep, exactly. Yeah. So that's where I'm finding a lot of value in A, learning and understanding this whole process, B, being part of it as both a VDC engineer at a contracting company, and then also being an architect for this specific case study.
I think there's another thing that really I keep running into in just about every job. I'm pretty sure anyone that goes out there and scans, it's about trust. And does the client trust or the contractor trust the data that you're providing them? Like, is that accurate? We could say till we're blue in the face, like, hey, the manufacturer of this scanner says we could be within 1 millimeter or 2 millimeter of tolerance, but do they trust that the data is accurate? And I guess it all comes down to, you know, how good are you at scanning and registering that data? What do you trust it? So conveying that
How
trust.
accurate are you with your tripod?
Yeah, exactly. How level was your tripod when you decided to take that scan? I mean, I can go on forever about some horror stories that I've had working with other data. And I think that's kind of the one thing is tough for all of us, is getting data from another source that you didn't provide or grab yourself. It's tough to trust that that data is going to be accurate, so that way you can perform your job in the best way possible, which is, of course, taking care of your client or doing well on a project, because it's our reputations on the line at all times. And I just recently ran into that with a project that we're on. So someone else did the work. It didn't come out accurate. It wasn't right. And we had to come in and basically redo that work and try to convey that trust. Like, it's accurate, guys. We got this. But to, you know, have Jackson to prefab those windows, like have him come out on a plane, if he doesn't trust your work, if I'm Jackson, I don't trust what you did, I'm on a plane, because I want to make them twice. Not unless they're going to pay for it twice, then I don't care. But at that point, you have to have that level of trust. So I think conveying that trust with whoever you pick, contractor or whoever. I mean, I think Nathan should just self-perform it. He should just be the contractor and hire everyone that he trusts to come work on it.
Well, the way too is getting the contractor to help drive this process, having a roadmap on how to get the data that is clean, that can be used for production, needs to be driven, in my opinion, by the contractor. A design build approach is the ultimate way that, you know, they've got skin in the game for the production and the end result, more so because they're having to make sure that the trade partners and subcontractors are delivering. And it's not just getting to the design, getting through permit, and then releasing it for bid and production. So I think, you know, with this kind of workflow, we'll see a return to the master builder, if you will, where you had the architect was the builder, which is what happened in a lot of these old homes and old buildings, is you had that master architect there basically creating DFMA on the job site. Like, nope, this is how we're doing it. And so getting that builder who is technologically savvy and able to help drive that process from a design standpoint through production is the way to get it to scale on big projects as well. But I think, to get the lessons learned captured and then get a roadmap that bigger outfits can use, starting on a small scale project like this is going to provide invaluable information that can be scaled.
I feel like we could just insert a link here to our roundtable that we did, like, I don't know, maybe a month or two ago. We were talking about, like, you know, if the owner or whoever is sourcing the project doesn't set the expectations of what tools are we using, what is the accuracy we need, and then how do we trust the data but verify? So how can Jackson verify? How can we have another person come in and check this? Or because if we're all relying on it, we need to make sure that the source of truth is accurate, or, you know, all the dominoes down the line are going to fall out of place. So that was a discussion we had previously, where if you don't have one person coordinating all of it, if you don't have group buy-in, if you can't verify, trust but verify, then this whole process falls down, because we're all going to revert back to our normal ways to cover our asses, which we keep bringing up over and over again.
Which is what
work and
builds the waste in our industry.
Yeah, I think I think about the jobs. My past company was design build, and the area, we'd spend millions right on the VDC side with 4D scheduling and for prefab and for 3D coordination and modeling for design, all for things to kind of sometimes on certain jobs fall apart. And I think the important thing is, it is good if you have the ability, and probably on larger scale jobs, to go and scan again, because you have to have some form of accountability. Because if once things start getting installed wrong, the chips start to fall. Yeah. And so you've got to be very intentional that if you're going to do the investment, I think initially that there is some sort of mechanism to track how that investment compares to what is happening in the world, whether that's just doing another scan and doing a visual analysis, et cetera, or with reality capture data of any sort, right? If that's through drones.
job site walk like StructionSite's got. They kind of have the verification.
Yep.
Mhm.
Yeah.
Is there
I think it
anybody
comes
out there
down,
doing this as a service where you can, just have them come out and do it all, scanning for you and deliver it?
Yeah, you can do that, but then again, you add that extra layer of trust. Is that if you're going to another contracted service, what if there is a small variable that they're off on? Then you got, you still got bad data potentially, and that person maybe has 5 or 6 other jobs that they're working on. If you keep it in house, in my opinion, and the builder, so you have maybe a project engineer on the project, or the builder is the one driving the scans, they're making sure that on that project they have the most to lose at the end of the job by passing out to somebody else. You're still going to be spending a lot of time coordinating it with outside resources.
I want to say it was Ben who brought this up in one of our past roundtables where, someone scans, the architect may have scanned, they may have been provided something, but your team still goes in and scans again to verify. Was that you that brought this up?
I did bring that up. I think that was a couple months ago.
Yeah.
That was in the case of like floor flatness tests, where we'll do a scan and provide an analysis of the floor and then provide that to our flooring subs. And then some of them are like, oh, this is great, thanks for sharing. And then others are like, well, we can't trust this for liability purposes. And then they have to go do their own anyways.
Yeah.
And it's like, we trust you, but we don't trust you.
insert link to the legal.
Oh God, yeah, back to the legal roundtable. Don't, Dustin, now we're going to Is this why your company has Flywheel in its name? We're in the flywheel here. And then the other thing that we haven't hit on at all is every one of these DFMA trades that are going to be delivering certain parts and pieces all have different tolerances. So, Jackson, your pieces may have a certain tolerance that the adjacent surface has a different tolerance of. So how are we, if we're doing this whole process where you scan, you create the model, you're able to design for manufacturing, then you have to, as things get installed, verify where they were installed so that the other parts and pieces can be made, or, what are the tolerances we're going to fit within, which is a whole other can of worms.
Right.
That you just don't talk about that. I mean, because you're getting into, okay, well, now that means we all have to model to a certain tolerance and accuracy.
Oh,
and
no,
I can tell you that.
I don't think everybody has to model to the same tolerance and accuracy. I think it's important to know what things have, like if there's something a 1/16 of an inch tolerance, right? Because it's steel, or it is some sort of prefab system. Those specific items may have intentional tolerances you have to model to. And then everything else is nominal with 1/8 of an inch, if it's walls, whatever. Like you have your normal or 1/4 inch, depending on the thing. I think you just have to kind of choose and be kind of intentional about what that certain thing is.
And I think that's
again, knowing that end user for each one of these steps is important, because I personally don't need anything to get a permit.
Yeah.
Right? I mean, I can give them a hand sketch to get a permit. But at the end of the day, Nathan going this DFMA route on this project needs to pass on very accurate information to the next guy. So we can utilize, what I'm doing inside of Revit, which is very orthogonal, to get what we need. But then at the same time, we have to have like that Verity tool to identify where those tolerances are off to create those, more minuscule details.
Yeah.
And I think, speaking from a wood window perspective, or if we do a prefabricated dormer system, kind of like we explored, we can build understanding that, wood can be planed down. There are certain things at that point that the dormer, as it integrates with the roof system, is going to have some kind of, flashing up to it or something like that. So we can, in certain areas, the tolerance is not going to really be that. You can still adjust it because it's wood, right? So we're not looking at like scanning in a pharmaceutical plant where you have to have floor flatness exactly what. You've got more flexibility, especially in a residential space, to be able to change some things on the fly, and really, especially when you're working with wood, playing things down where, you might have a little bit more work, but at that time, it still saves you a ton of potential wasted time from figuring it out on site and building it completely on site.
Yeah, everything shrinks here in Denver, so just make it bigger.
Can do that.
Yeah.
And I think, you know, just we've got 3 minutes here. I don't know how time goes by this fast. Let's play this question back. How might we leverage the latest reality capture hardware and software to produce reliable as-built conditions in ways that enable DFMA of historic renovations so that, you know, we can minimize the amount of time on site? And I think what we've kind of talked a lot about is, you know, first of all, understanding what are the different types of data that we need to collect at the beginning. How can we trust those sources? How can we verify those sources? What are the tools that we're going to use to create these different outputs that then Josh is going to use to design and Jackson's going to use to manufacture? And some of the constraints that we're thinking about here are, you know, accuracy, tolerances, and how can we, you know, feed this information back into the model and continuously update things? What did I miss? We've got 2 minutes. I want to make sure that we've covered everything in this. How might we?
We talked about the consistency with the existing structure too,
Oh,
yeah. As it being historic.
Definitely.
One thing is how can we open this up for jurisdictions to have input, or open these files up as, you know, more jurisdictions come online with BIM or reviewing models? How can we incorporate them to give checks and balances throughout the process to make sure that we're not going down a design road, planning the thing, then they come and say, hang on, you can't do this. So incorporating AHJs and historic preservation offices or different things like that during the process, I think we need to have some form of communication checkpoint to make sure we're not getting too far ahead of jurisdictions that are still a good bit behind.
Yeah, and I throw out to there too, I think getting in tight with insurance companies, you know, I think that, you know, errors and omissions and also just insurance for builder's risk are expensive. That's a business thing that all businesses have to carry, right? Depending on what you're doing. And if somehow they were bought into understanding a workflow like this, it could also reduce those rates on insurance and can be more compelling to kind of move the industry forward because you're getting your rates are lower, or, you know, and who knows, right? So
we're putting the tracker in our car. We're saying you can track how fast we're going if we get cheaper insurance.
Yeah, yeah.
And then that's cost savings ultimately to the owner, because then our prices come down because we're not having to cover as much because we're trusted to deliver better.
Yeah, and it guarantees that jurisdictions get an actual building that's what they're going to be, what you'll be paying taxes on. Yeah, like
that's what comes out to.
Reduce permitting fees too, if you're not revisiting it.
Yeah,
and then there's some of the areas I grew up on the East Coast, and some of those design reviews for historic renovation are brutal, and they just don't actually make sense because they don't have the context of what it looks like today and what it looks like next adjacent buildings. And if they, you know, that if they have that information, they would give you a little leniency here, or, you know, especially for like things like windows that are already replaced or colors that are already existing around the neighborhood. That would play into getting permits that would suit the owner better.
That's a great point.
So I feel like our answer to Nathan is going to be that he needs to be the contractor to hold the cards. And he needs to make sure that he's the one coordinating everything. And if it's not him, he's got to find someone that he really trusts so that they can, you know, keep this momentum moving forward.
And me as the architect, I take no responsibility for anything.
I think Ben and I said committed to coming out there, I guess. Well, it looks like we signed up for making a trip to Denver.
Yeah, I feel like this was planned. I feel like there's some ulterior motives for this breakout session. I don't know.
Yeah.
You guys are all now on payroll.
Hey.
Yeah.
You're all hired.
All right.
Ben. If it's not Nathan, it's going to be you managing this job.
All right.
My work stops at the scanning. I'll be at Topgolf.
That's all contractors do anyways, right? It's golf. No.
Yes. So Jackson, you've got everything you need. You're set for DFMA, right?
Oh yeah, getting there. I got a team that's really excited about how to figure out this workflow, both from a traditional manufacturing, wood manufacturing, where we've got our routers, and then how to get CNC axis, like 5-axis machines, ready for larger scale production. Because we can get all this information and get it so that, yeah, we can do it with CNC machines. But if the local wood shops and the local preservation outfits can't get up to speed with using this, it's going to be for naught. So being able to protect them and say, here's how you get your knife design, here's how you use this file, and bring them up with it. You got to bring up the little guys because, you know, not everybody has the big budgets to be able to do all this. And so that's what we're after, is trying to make this so that it can be DFMA for all.
We're down.
Awesome.
All right. See you guys in the big room.
Sweet.
Joe, you're in your COVID disguise. I just sat in a room with you and didn't even realize it was you.
Yeah. This is 12 months of no haircuts. That's what it looks like.
Do you have the full man bun? Are you able to rock it in Texas, or do they still give you crap down there?
Oh, it's outlawed down here, but I can pull it back. Yeah.
Well, at least you have hair.